Okay, YouTube, in my last video we had discussed describing data sets by observing the median as well as the spread of the data by looking at the range. And the fashion that we used to do this was to find what we call the 5-number summary, which is taking our data set, putting it in order, splitting it into quartiles, and then graphing this with what we called a box plot. In this video, what we're going to do is we're going to explore the nature of what we call outliers. So again, to review, in my last video, what we had been looking at were quiz scores of 3 separate classes that had taken, say, a ProbStats quiz and how they performed on it by comparing their box plots. So when looking at the performance of these 3 classes here, we have Class A, Class B, and Class C. My question was, going forward, was do we see any data values within these data sets that are outliers? And one data set in particular, we say, I guess this one over here as well, we could ask ourselves, are these values outliers? Because an outlier, by definition, an outlier is just a really large or really small data value. And not just that, but it doesn't match the overall trend of the data set. So that is to say, if all these scores were, somewhere between, we could say like 74 or 73. 74 here was our Q1, or 73 was our Q1 on this data set B here. And our Q3 is like 80. 50% of our scores were between 73 and 80. Then if I had a score that was like 100, or a score that's like this, maybe the 60 right here, it doesn't really match where the middle of the data set is. So in order to find outliers, one thing we're going to have to do is we're actually going to have to take into account, well, how did the middle 50% of our data do? And one measure that we use to describe the middle 50% of our data is to find what we call the interquartile range. So we say in order to determine whether or not outliers exist in a data set, we must first be able to determine a measure of variation, or a measure of spread of our data, called the interquartile range. So recall that the range, by definition, is the maximum value minus the minimum value. And geometrically speaking, for instance here, the range on this graph here would be the distance on the number line that this box spreads, because this top value is our maximum and the bottom value is our minimum. Okay. The idea here, though, is this. If we want to find the range of our middle 50% of data, first of all, we're going to call this the interquartile range. Remember, inter means between. So between which quartiles? Well, between the middle, 2 quartiles, or the middle 50% of our kids that scored on this quiz. So by definition, this is the definition of the interquartile range. It is not the max minus the min, but it is Q3 minus Q1, where Q3 is this value right here, and Q1 is this value right here on a box plot. We could say that this is Q1 right here. Q1. That's not very clean. Then we say this is Q2 over here. Q3. Pardon me. But the distance between these two things. So one thing I want to do is I want to illustrate what is the IQR geometrically speaking. And geometrically speaking, the IQR is the span of the box on the data set, because it is the spread of the middle 50% of data. So the IQR being defined as it is, we say again, geometrically speaking, it's the span of the box part of the box plot. It's how far spread the middle 50% of data is. That's going to be a lot more resistant to outliers than the entire data set. That is to say, if you were to add in a score on this quiz right here, somebody got a 0, which would be, if this is 60 and this is 100, man, 0 is going to be like over here somewhere. The whisker's going to go all the way out here. The idea is that the range is going to be thrown off, but the interquartile range, the distance between Q3 and Q1, that's not going to be tossed off very much at all, if at all. So that being said, let's go ahead and find the IQR for these 3 data sets. I say, what's the IQR of Class A? And so Class A was this first class over here where we've already found these 5-number summary values, and we say, well, Q3 in this case is 90 and Q1 is 82. So if I said, how far does this middle 50% of our data span? We'd say it's 90 minus 82, and so we get a distance of 8 units essentially. So we would say 90, we're just going to write these out, 90 minus 82, the IQR is 8 percentage points. So I'm going to label this 8 points, We got to label things. We say IQR of Class B. Well, how far did the data spread on Class B here? We say that Q3 is 80 and Q1 is 73. So we'd say, well, the distance from 80 to 73, not the total range, but the range of the middle 50% of the data, is 7 points. So we could at least say this. Class A, we found this out in the first video, you performed much better than these other 2 classes over here, but especially better than B. But I would say that even in Class B, they had a more consistent interquartile range than this one did. It was only 7, whereas this one was 8. And then the IQR on this last data set, we say 80 minus 74. 80 minus 74 is an IQR of 6 points. So once we discover these, the whole key to testing for outliers is going to be knowing this IQR value first. But that is what the IQR is, and that is how you pinpoint it on the graphs. Okay. So now that we know how to find the IQR, let's explore this procedure that I give us for finding outliers, testing for outliers. So when you're given a data set, it's not that you have to draw a box plot, but this is going to help us visualize it. But when you're given a data set, to find the outliers, or to test for outliers, the first thing you always want to find is you want to find this 5-number summary. And then using this 5-number summary, we'll identify Q1 and Q3, because the first 2 steps of this basically say this: find the IQR, or find the 5-number summary, and then find the IQR. So we do have the IQR for all 3 data sets. What we're going to do is we're going to test this first data set first for any outliers, which it doesn't look like we had very large, very small data that didn't match what the rest of the data did here. So step 3 is going to be this. We are going to take your IQR and you're going to take it times 1.5. Essentially what you're doing is you're taking this distance of the box, this middle distance, and you are making it 1.5 times its original length. So if I split this in half and I say, okay, well, 1.5 times that length, if I were to take this and add it on to the end of it, that right there, this is our measuring stick, okay? And that's going to represent 1.5 times this middle distance here. So for Class A, we're going to test Class A for outliers, Class A. We found the IQR. The IQR is equal to 8 units. We're going to say 1.5 times the IQR would be the same thing as 1.5 times 8, and 1.5 eighths would be equal to 12. So this number, I'm going to box it here. This is very important because this number right here, on steps 4 and 5, I say step 4 is subtract the number that you just found in step 3, which is this 12, this 1.5 times the IQR. We are going to take it away from the value of Q1. Okay, this is the first number in our test interval. So that is to say, what we're doing is we're going to take this measuring stick, we're going to pick it up, and we're going to subtract it off of Q1 here, which, geometrically speaking, we say this distance right here, we're saying we're going to tack it on to the beginning of this, and if you subtracted it off of this Q1 value, you'd be taking your measuring stick and going to the left this far, and we're saying, look, does anything fall to the left of this on your box and whisker plot? And in this case, it doesn't. And if we were to take this measuring stick here and I say let's tack it on to, starting at Q3, this is our step 4 here, we're going to add this 12 from step 3 onto the value of Q3. So in other words, we're going to take that measuring stick, we're going to tack it onto the end of the box. So take this measuring stick and move it over. We say tacking it onto the end of the box, it'd be about, maybe right here. So we're saying, really, does anything fall in the original data set outside of this range right here? And it looks like all of our purple stuff was in between this little green range. So we're going to verify this now numerically, but that's geometrically what it is that we're doing. So we're going to say, let's take 1.5 times our middle 50% of our data's spread here, which is this 12. And we're going to say, okay, so Q1 minus 1.5 the IQR, and Q3 plus 1.5 the IQR. And in either instance, let's see in this first one here, we say that, I can just point this out here, we say Q1 was 82. We're going to say 82 minus 12 is 70. And then we say, okay, Q3, which is this 90 right here, and we say 90 plus 12 is 102. And what we get right here, and I'm going to label this, is I'm going to call this like a test interval. Okay. So the very last thing we want to do with respect to this test interval is this: assess whether or not any of the data in the data set lies outside of our test interval. So that is to say, in the original data set, were there any scores that were less than 70 or over 102? Because anything less than 70, we'll call it, at least a slight, outlier. And anything over 102, we'll call it a slight outlier, a slight upper outlier. So I look at this data set and I say 80. 80 is not less than 70. And you notice that I was kind of spitballing here, but this 70 is like 1.5 times the middle distance to the left of Q1. And then we said 102, I was just kind of drawing this in, eyeballing it, but we say that 102 would be about right here, where we've tacked on 1.5 times this middle distance to the edge of the box. And we notice that nothing falls outside this range. So what we could conclude is this: we've tested, Class A and how they did. We could say there are no significant outliers. Significant outliers. Okay. So this is how we test for outliers. So now that we have this method, what I want to do is I want to test these other 2 data sets for outliers much quicker than what we did here. And I think that maybe this bottom 60 might be an outlier on this set here. So we're going to take this IQR. We say 7. We say Class B here. We'll go a little bit quicker. We say IQR is 7. We're going to take 7 times 1.5. So 1.5 of these 7s. And you can get a calculator out, but we'd say it's 7 plus another half of 7. So we'd say 7 plus 3.5 is 10.5. And what we're going to do is we're going to take Q1 minus 10.5. That is, we're going to take the Q1, which is 73 here. We're going to say 73, take off 10 would be 63, take off 10.5 would be 62.5, 62.5. And then we say, okay, well, let's take Q3, and we'll add on 10.5. And our Q3 in this case, just observing here, is this 80. We say 80 plus 10.5, and we get 90.5. So were there any data values less than 62.5 on our test interval here? And what we can see here is this. When I flip back over here, we say that definitely this 60 was outside of that range here. If this is our middle range, we say add on another half of that middle range here, and then tack that on to the beginning of this. We'd say about right there. You can see that 60 falls outside that range. And then we say, okay, were there any scores bigger than 90.5? And in Class B here, the biggest score is 85. So we have nothing bigger than 90.5. So we could conclude that 60, we say 60, the data value of 60 is an outlier. And you could even describe how strong the outlier is. You might say 60 is a slight outlier. And then last but not least, we say Class C. Was that person that got the highest score on this quiz, that didn't match everybody else's score, this person right here, this 91, all over here, is it an outlier? So again, we're going to say, well, let's take our IQR. In this case, we said the IQR is 6. 1.5 times 6, we'll inflate it to 1.5 times its original size, and then we'll just take this off of Q1 minus 9, and Q3 plus 9. And so we get Q1 minus 9. Our Q1 here is this 74, so we see 74, take away 9, 65, and then we'll take our Q3, which is at 80 over there. 80 plus 9 is 89. So this is our test interval, and I say, were there any scores less than 65? There were no scores less than 65. We had one close to it, but we could say, were there any scores greater than, and I think we said here, 89. And so anybody above an 89, 82 wasn't, but 91 was. We could say 91 then. 91 is an outlier. Okay, and this is how you test for outliers. Cheers.